Today I'm going to go over your Geometry Unit 8 review over probability. So the first thing we talked about was sample spaces. So in our first example here, our first problem, a concert you're buying a t-shirt. The shirt comes in large, medium, or small, and you can get the short in short sleeve or long sleeve, and you can also get it in white, red, or black. So we're going to draw a tree diagram to illustrate all of the options. Okay, so first option is large, medium, or small. So I'm going to do three branches of our tree, really. And I'm going to label it L, M, and S. Off of that, we have either short sleeve or long sleeve. So I'm going to do 2 branches for each of those. So LS, SS, I guess I do SS, LS, SS, LS, SS, LS. Now very carefully, we're going to do 3 branches off of each of those. So 1, 2, 3, 1, 2, 3, and so on. Okay, and we'll label all of those with white, red, black. Okay, then to get our sample space, we're going to go down each branch. So we go here, 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 and so on. So first one's going to be L, S, S, W, large short sleeve white. Then we have large short sleeve red, and so on. So we're going to follow each of these branches. So we go through the whole tree and we get all of our different options, which is our sample space. All right, so next, you are getting dressed for school. You have 5 pairs of pants, 6 shirts, and 7 pairs of socks to choose from. How many different outfits are possible? So this is just a simple counting principle where we're going to multiply the 5 pair of pants times the 6 shirts times the 7 socks to get a total of 210 different outfits you can wear. Okay, next, probability and counting. So consider the experiment of picking 1 month of the year at random, and then we're going to find various probabilities. So our first question, we want the probability of picking a month ending in Y or starting with an A. So ending with a Y, we've got January, February, May, July. Starting with an A adds in April and August. So we have 1, 2, 3, 4, 5, 6 of the different months meet that criteria out of a sample space of 12 months. So that's 1/2 or 0.5 or 50%. So all of those are acceptable ways to answer the problem. A month ending with an even number of days. Okay, so on the test, if you're not sure, questions like this, how many days, feel free to ask. So January through December, here's our number of days. So the number of ones that have an even number, so that's going to be 28, 30. So we've got 1, 2, 3, 4, 5 months have an even amount. So 5 out of 12, which is 0.42 or 42 or 41.7% when you type it in your calculator. And a month with 30 or more days. Well, that's everything except for February. So that's 11 out of the 30 or out of the 12 have 30 or more days. So as a decimal, that's 0.92. As a percentage, that is 91.7%. Okay, what is the probability that you draw a card from a standard deck, 52 cards with no joker, and you do not draw a face card? So I'm going to go through kind of 2 different ways you can think about this, and both of them are perfectly acceptable. First, let's think about how many face cards they are. So Jack, King, or Queen, there's 4 suits. So there are 4 times 3 or 12 face cards. So the first thing I can do is use the complement rule, which says that I take the probability of getting a face card, which would be 12 out of 52, and do 1 minus that. If you do that, you get 0.77 or 76.9%. Okay, you guys are good at using your calculator. Your other option is just to simply figure out our favorable options. So if 12 of them are not favorable of the 52, 40 of them are favorable, and then again you'll get that same answer. So it's really just what makes the most sense to you or how that works out. Combinations and permutations. So permutations, the order does matter. Combinations, the order does not matter. So we're going to look at these scenarios. We are not figuring out the actual numbers. We're just figuring out if they're permutations or combinations. So how many ways can you rearrange the letters of math? Doesn't have to make a word. That is going to be a permutation because the order does matter. How many 4-topping omelets? That is a combination because it doesn't matter if you put cheese and ham or ham and cheese. Those are the same omelet. And then your bike lock requires 4 digits that do not repeat. Order matters here, so that's going to be a permutation. Okay, next up is geometric probability. So our first one, point E is selected at random on XY, the length of XY being 9. Okay. What is the probability that E is on AY? Well, AY is 7. So my probability is going to be 7 out of 9, which is 0.78 as a decimal, or 77.8% as a percent. All right, spinners are an example of geometric probability. So what is the probability that the spinner lands on green? Well, green occupies 30 degrees of our 360-degree spinner. So that would be as a fraction 1/12, as a decimal 0.083, as a percent 8.3%. Find the probability that a point chosen at random is in the shaded region. So we have some geometry work to do here. And I'm just going to organize this just step by step. So first I'm going to find the area of the circle. Area of the circle is going to be pi r squared. My radius is going to be 6 plus 2, or 8. So that gets me 201.1. Then I'll find the area of the square, which is going to be, if this is 2, that means that's 4, and we're going to assume it's a square, so that's 4. 4 times 4 is 16. Okay, my shaded area, I'm going to take the circle and I'm going to subtract the square. So that's 201.1 minus 16, which is 185.1. So then the probability of our shaded area is going to be the shaded area, 185.1 over 201.1, which is 0.92, or 92% chance we get in the shaded area. Okay, next we're looking at compound events, meaning we have more than one thing happening, and these can be independent or dependent. So a coin is tossed and a die is rolled. Find the probability of tossing heads, then rolling a 5. That would be independent, so we just simply multiply the two probabilities together. So tossing a head is 1/2, rolling a 5 is 1 out of 6. So my fraction is 1/12, my decimal is 0.08, my percentage is 8.3%. Okay, these next two are similar with a very key phrase that's different. So find the probability that a card is drawn from a standard deck of 52, then replaced. So what is the probability of drawing a 10 and then another 10? So we pick the 10. There are 4 10s in the deck. Then we're putting it back. So there's still 4 10s in the deck, and there's still 52 cards. So that's 16 out of 2704, which is a small number, so 0.0059 as a decimal, which is 0.59%. So not even 1% chance that happens. Okay, the next one is the same scenario, but it is not replaced. So the first probability stays the same. Okay, but if we take a 10 and we don't put it back in, we are left with 3 10s in the deck out of 51 cards. So this probability is 12 out of 2652, which as a decimal is 0.004, as a percentage is 0.45%. Okay, our next problem. A drawer contains 8 red, 3 blue, 7 orange, and 2 yellow socks. The odd number socks kind of bother me, but whatever. One sock is drawn at random, and once it's selected is not replaced. So find the probability that first you pick out a red sock. So we have 8 out of there, a total of 20 socks if we add all those values together. We are not replacing it. So there are 2 yellow socks, but now there's only 19 socks in our drawer. So we get 16 over 380. As a decimal is 0.04. As a percentage, 4.2%. For 15 and 16, determine if the events are mutually exclusive. So mutually exclusive means that there's no overlap. So drawing a card and getting a 4 or a diamond. This is not mutually exclusive. Okay, because there is an overlap. There are diamonds that are 4s or 4s that are diamonds. Okay, drawing a card from a standard deck and it getting a red card or a club. Those are mutually exclusive. Okay, because there is no overlap. Okay, next. According to our table, if a student is chosen at random, what is the probability that a student in a club is a junior or on the Knowledge Bowl team? So we're going to take the probability that they're a junior plus the probability that they're on Knowledge Bowl and then subtract the overlap. Okay, or you just count up the correct squares, but we're going to apply this. So the probability that they're a junior, so if we add these rows up, we get 32. If we add everybody in the chart, and you can do that math, is 74. Knowledge Bowl, 3, 5, 2 is 10. So 10 out of the 74 are a Knowledge Bowl, but we counted this set of 5 twice. We counted them in the Knowledge Bowl row and the junior column. So we're going to subtract out that overlap. So 32 plus 10 minus 5 is 37 out of 74. That is equal to 0.5 or 50% chance you pick a junior or a Knowledge Bowl participant. A spinner has 18 equally sized sections, numbering 1 through 18. What is the probability that the spinner lands on 12 given that it's an even number? So there's only one 12. If there's 18, that means there's 9 even numbers. So if we know it's even, there's only 9 options that we can choose from. All right, there are 17 students participating in a debate over longer school days, but only 4-day weeks. The students randomly draw cards with numbers 1 through 17. If you draw odd, you are arguing in favor of longer days and 4-day week. If you draw even, you are arguing against. So if Levi is arguing in favor, what is the probability that he drew a 9? Okay, so to help illustrate this, write out the numbers 1 through 17. So how many of them are odd is 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 odd numbers between 1 and 17. So if he picked an odd, he's got a 1 in 9 chance, which is 0.11 or 11.1%. If Autumn is arguing against, she picked an even number. The probability that it was a 2 is 1 out of their 8 even numbers. So this is 0.125 or 12.5%. So when in doubt, always draw out your sample space so you can see what you're working with. And in our last section, we talked about two-way tables. So this just has a lot of information in it. So students were surveyed about whether they do or do not participate in after-school activities. So we've got 9th graders, 10th graders, those who participate, who don't participate, and then the totals for each thing. Okay, so what is the probability that a student participates in activity given they are in 10th grade? So I'm actually going to start with the denominator. So we know they're in 10th grade, which means we have a total of 466 that we are working with there. The number of those who participate in activities are 256. Okay, second one, if the probability that a student is a freshman, given they don't participate in activities. Well, the number that we're working with here is out of 488. Of the 488, 278 are 9th graders. Okay, so those are the questions that you need to be able to answer for your Unit 8 probability test.